All right, we are gonna work in chapter 10, lesson 7. Here we're verifying trig identities. It's pretty simple to, similar to the last video we did from chapter 10, lesson 7, but we're just gonna verify that identities are true. Okay, we're gonna make the left side of the equal sign equal the right side of the equal sign. So for this first one, I'm gonna take the left and mess with it and try to get it to look like the right. I know, sort of crazy. So first of all, I'm going to do a little magic and split up cosine 3x into cosine 2x plus x, right? Then I can use the sum formula to alter this. So if we look at chapter 10, lesson 6, we had sum and difference formulas. We're going to use this sum formula. You'll have to go back and look at it in your book. But when I have cosine of a plus b, it's the same as cosine a, cosine b, minus sine a, sine b. Right? So that is straight from lesson 10.6. Now, since 10.6, I have learned tricks with double angles. So I'm going to page back to, you hear me paging these because I don't have them memorized. I've got the double angle formulas from section 10.7. So I'm going to change out these two items from the formula, from the identity that we're working with, we're trying to verify. Instead of cosine 2x, I'm actually going to replace that with 2 cosine squared x minus 1, and I still have that cosine there. And then replace the sine 2x with the double angle formula, 2 sine x cosine x, and we still have that sine x there. So let's do some multiplication or distribute that cosine within the parentheses. That gives me 2 cosine cubed x minus cosine x, and then minus 2 sine squared x cosine x. Next, it looks like I can perform some magic by replacing this sine squared x with a Pythagorean identity. So let's rewrite everything. Cosine cubed x minus cosine x minus 2. And instead of sine squared x, I'm going to put in 1 minus cosine squared x. That is your Pythagorean identity times cosine x. I have some multiplication to do here. First, I'm going to distribute that cosine x in the parentheses. I get cosine x minus cosine cubed x, and then I actually need to distribute this negative 2 that direction. So negative 2 cosine x plus 2 cosine cubed x. I'm going to rewrite everything on this side. I don't want to lose anything. All right, now it looks like I'm going to be able to collect some like terms. These are going to give me 4 cosine cubed x, and it looks like these will give me negative 3 cosine x. So let me get a new slide and write that down. So there I had 2 cosine cubed x minus cosine x minus 2 cosine x plus 2 cosine cubed x. These two items will give me 4 cosine cubed x, and these two will give me minus 3 cosine x. Cool, and we're done. We verified the identity. the left-hand side equals the right-hand side, and life is good. Okay, now we're going to solve trig equations. So example 5 was verifying, example 6 is solving, and again, these are the ones you guys love where I'm solving within a certain range, so I need to pay attention to my signs, and it gets a tad bit complicated, but it's okay. I'm going to solve this in that range. So if I look at the original equation, it looks like here I'm going to change that with a double angle formula. That gives me 2 sine x cosine x plus 2 cosine x equals 0. I think I can factor out a cosine x and a 2. And I'm left with sine x plus 1 equals 0. Here I actually have what looks like a formula that we've learned how to solve. Like if I made this 2x y plus 2y equals 0, I can factor it out to 2y x plus 1 equals 0. I'm doing this because it might make better sense. That means 2y equals 0, y equals 0, or x plus 1 equals 0, x equals -1. So this is the type of thing I'm doing on the left hand side of your screen in black. Here I have 2 cosine x equals 0. If I divide both sides by 2, I get cosine x equals 0. And then we just go cosine to the -1 of 0 equals x. X equals, if I go to my unit circle, cosine is 0 at 90 degrees and 270 degrees. So that right there are 2 of my solutions. But I can also say sine x equals -1, or sine to -1 of -1 equals x. Therefore here, x would be equal to 3 pi over 2, which you can check on your unit circle. So those are 2 answers that I would get for that range, domain, for that domain of the whole unit circle. All right, here we're going to find general solutions, and if you remember correctly, that's where once we would find our solution, we would find the repeats of it by adding a full revolution of the unit circle. So let's go ahead and try it. Here I have 2 sine x over 2 equals 1. If we divide both sides by 2, we get sine x over 2 equals 1/2. We can actually solve it from here and say sine to the -1 of 1/2 equals x over 2. If I plug that into my calculator, I get x over 2 equals pi over 6, which is 30 degrees. Okay, I can actually take that and revolve it around the unit circle by adding 2 pi in. But for the sine function, if I'm at 30 degrees or pi over 6 and I'm positive, I can also be over here. So if that's 30 degrees, that's 30 degrees. 150 degrees, which is 5 pi over 6. So x over 2 can also be 5 pi over 6 because that's the other part of the unit circle that gives me a positive value at 30 degrees. So here are 2 answers. What's weird is that's still pi over 2. So I'm going to go ahead and multiply everything by 2 to get rid of that, and that gives me x equals 2 pi over 6, which is pi over 3, plus 4 pi n. I know that's weird, but that's actually how we're solving it. Same here, cancels that out, and I get 10 pi over 6, which is 5 pi over 3, plus 4 pi n. So I can actually say pi over 3 plus 4 pi n and 5 pi over 3 plus 4 pi n. Cool, so those are the general solution. I've got a general solution for pi over 2 and a general solution for, a general solution for x over 2 and a general solution for x. Fun. All right, let's try a few extra practices. So here we have verifying the identity. I've got the left and the right side. This is going to work the same as the other example we did, where I'm going to change this into sine 2x plus x. And that's I'm turning my book page back to 10.6, my sum formulas, where I've got sine A plus B equals sine A cosine B plus cosine A sine B. So I can mess with that. I'm going to take this double angle formula, this double angle. Switching back to 10.7, you hear me moving my pages in my book. I'm going to take that sine of 2x and change it into 1 minus 2 sine squared x. Right? And over here, I can change this sine 2x into 2 sine x cosine x times cosine x. Cool. Okay, collect some like terms. Well, gather some things. 2 sine x cosine squared x plus sine x minus 2 sine cubed x. Crazy, I just got a sine cubed. This is where I sort of forget what to do, but I recognize this right here and I remember what I did in my last example. I've got 2 sine x. I'm going to change that into 1 minus sine squared x, which is the Pythagorean identity, plus sine x minus 2 sine cubed x. I can distribute this 2 sine x minus 2 sine cubed x plus sine x minus 2 sine cubed x. Let's see. I've got these two, which gather 3 sine x, and these two, which gather to 4 sine cubed x. Phew, that's tough work. Good job. Okay, let's verify this identity. I've got the left side and the right side. Let's try this. Instead of cosine 10x, let's do cosine 2 times 5x, because that looks like a double angle that we know how to use. So I've got cosine 2x. I'm looking at let's try this one. That'll give me 1 plus, instead of this, I'm going to use an identity, a double angle formula, and say 2 cosine squared 5x minus 1. Because those cancel. I'm left with 2 cosine squared. Ooh, I got lucky. Yeah, it matches. Woohoo! All right, here's where we're solving. Let's see, I have tan 2x plus tan x. I do have a double angle formula for tan 2x. That would be 2 tan x over 1 minus tan squared x plus tan x equals 0. Let's try to get it all over the same denominator. I'm going to move this 0 over because I want to multiply this by 1 minus tan squared x over 1 minus tan squared x. So this is a hard one. 2 tan x plus, I'm going to distribute this, tan x minus tan cubed x, all over 1 minus tan squared x equals 0. What do I have here? Got a 2 tan x plus a tan x. That gives me 3 tan x. All right. Minus tan cubed x all over 1 minus tan squared x. Equals 0. I need a new page. I'm going to copy that over to my new page. So I'm at 3 tan x minus tan cubed x all over 1 minus tan squared x equals 0. Whew. Well, amazingly enough, if I had something as simple as, I don't know, 3x minus x cubed over 1 minus x squared, which is really what I have up there, just with tangents, and that's equal to 0, I could actually cross multiply and just know that that denominator is going to go to 0. Okay, so let's take the numerator, 3 tan x minus tan cubed x equals 0. Factor out my GCF, which is tan x, 3 minus tan squared x equals 0. So tan x equals 0, or tan squared x equals 3. Tan x equals plus or minus root 3. So we have two possible answers. For tan x equals 0, that actually occurs at x equals 0 and x equals pi. Okay? If you look at the unit circle, 0 and pi, because tan is opposite over adjacent. Tan x equals plus or minus the square root of 3. That occurs at a few more things if we look at the unit circle, or you can look at your awesome chart. I'm looking at my unit circle, the chart. That's going to happen at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, check out that chart you guys have. It's going to show all of those. Okay, that was a tough problem. I'm glad you stuck with me. Okay, solve the equation. This one's a tad bit easier. I'm going to subtract 1 from both sides, and then divide both sides by 2. Then I can figure cosine to the -1 of -1/2 equals x over 2. Handy dandy calculator. Hold on, negative. That gives me 120 degrees. X over 2 is 120, which is 2 pi over 3. I can repeat that. Remember, we go around the unit circle over and over and over again, so I can add 2 pi n to that answer and still get the same answer. X over 2 can also equal 4 pi over 3. Which is 240 degrees. So I'm over here, and so that's 120. Oh, sorry, hold on. And 240 is the next one. Okay, those are both 60-degree angles. That's going to be plus 2 pi n. And remember, those are our x over 2 solutions. I can also make that an x solution by multiplying everything by 2. So I get 4 pi over 3, which I already have, with a rotation of 2 times around the circle, and 8 pi over 3, which is 2 times around the circle. Yeah, there we go. 2 answers. Okay, daily homework. As usual, I'm not going to work these problems out, but it's just great to double check that we remember how everything works. It'd be a great way to study, right? If you have any questions about these, I can definitely help you. Verifying this one. I'm going to push pause and fill them in. Be right back. All right, there you go. Half angle formula. General solution. Cool. That's it. That was the last slide. Nice job. That was an ending well earned.